All right, so today we're moving up a step, and we are going to be talking about higher order polynomials, or oh no, okay, polynomials of a higher degree. That's just a smile.
You're not presenting.
Oh, I'm not presenting. That would help. Thank you. I'm just talking. Okay, there we go. Higher order polynomials, or polynomials of a higher degree. So remember that the degree of a function the degree of a polynomial is this largest exponent value. And again, oh, that's a weird. All right, so here we have a degree is the largest exponent value of a polynomial. A polynomial is an expression with 3 or more terms. Okay, I'm not sure, that's probably some Algebra 1 stuff. You had monomial, which would just be like x squared. You have binomials, which are linear equations, ax plus b, things like that. And then after that, we just call them all polynomials. So first, there's going to be a few different topics that we're talking about with these polynomials. One of them is mainly graphs, right? How the graphs look, how they're set up, properties of the graphs. So first, we're going to talk about what they look like. Polynomial. Okay, so with graphs of polynomials, there's kind of two ways that we can classify them. We can say that they are continuous, which is a term that you'll be seeing later on at the end of the year and in AP Calculus. So continuous is just kind of what you think. It's a line or a curve that doesn't have any jumps or holes in it. Okay, so it's one the way I like to explain it is that continuous graph, you don't have to lift your pen or pencil up to draw it. Okay, it's one long continuous line. Okay, and then we say it's smooth because it's not jagged in any places. Okay, so this would be this could be an example of a polynomial function. All right, and we'll talk about what's called end behavior, right? How it looks going at the end. We'll talk about how many times it turns, things like that. Okay, so here are two graphs that are not polynomial graphs. So if you have something that looks like this, okay, this is not a polynomial because it's not continuous, right? If I had to draw this, there's no way that I can get from here to here without lifting up my pencil, okay? So that we would say is not continuous. Or if we see something like, an absolute value, okay? that wouldn't be smooth. Okay, we kind of have an edge there or an angle. All right, polynomial functions do not have a sharp turn like that. Okay. Let's see. We'll get to that later. All right. So the first thing we'll actually talk about is what's called leading coefficient test. All right. So again, just some refresher if it's been a while since you've heard some of these words. Coefficient is the number that's in front of your variable. Okay, so leading coefficient means it's the first coefficient when you line up your polynomial in descending order. Okay, so there's two things that we're looking at. Uh, all right, so again, our polynomial in standard form, it just means that we have it set up where our exponents decrease. Okay, so if this was to the fifth, this would be to the fourth, right, and so on and so forth. So here, our leading coefficient would be an, okay, and then we would say it would be the nth degree. All right, so if, like I said, if that was 3x to the fifth, it would be a polynomial of degree 5, and the leading coefficient would be the 3, the number in front of it. So right now, we're just focused on this first part, okay, the highest order. There's a few things that we can do just with this. Okay, so there's two parts, but we are going to be talking about end behavior. Okay, and that's how the function will look at its ends. So we kind of have two groups of classifications here. So the first thing that we're going to look at is okay, is my highest degree, is my highest exponent odd or even? So you may already notice this with, x squared and x to the third, okay? I'm running out of paper. I don't. Okay. So if it's even, the end behavior goes in the same direction. Okay. I'll explain this, a little further in a little bit, but for a quick example, we have x squared, right? My power is even, and here, my end behavior, I'm going up in both cases. Okay. There's a more mathematical way to explain that, and we'll get to that in a second, but that's just a quick example. I'll give you a minute to finish copying anything before I flip the page. Okay. Then our second classification for that is if the degree is odd, then our end behavior goes in opposite directions. Now you have your linear function, which is pretty straightforward, but if I had x to the third, okay, you can see as I go off to the right, it's increasing. Okay, as I go off to the left, I am decreasing. All right, so that's what we mean by opposite directions. So that's the first part, and we figure that out by the degree. Okay, the second part is if the leading coefficient is positive, if it's greater than 0, and then if the leading coefficient is negative, okay, we've seen this before, right? When this happens, it flips the graph, it reflects it, okay? So that changes everything. So what I'm going to do is I'm going to make a little chart to show you each situation. All right, so we'll start with odd. Okay, so when n is odd, our first one is going to be the leading coefficient is greater than 0. Okay, this is our normal situation. So this is how we write it. So this part is going to be new. So here we say as x approaches infinity. What this means is as we're looking at the graph moving to the right. Okay, positive infinity means that we go all the way over to the right. So we say as x goes to infinity, our function f of x also goes to infinity. Okay, now the hidden part here is that there's an invisible plus there. Okay, in the opposite direction, we say as x goes to negative infinity, right? So that just means I'm moving to the left. Our function also goes to negative infinity, which is down. Okay, so that's when n is odd and a is greater than 0. If a is less than 0, okay, that reflects it. And we end up with opposite end behavior. Okay, now over here, okay, again, I'm still having x go to positive infinity because I'm moving to the right. But now we flip this, and f of x is going to go to negative infinity. That means I'm going down. On the other side, okay, again, x going to negative infinity, just meaning I'm moving to the left. Then my function, f of x, is going to positive infinity. Now, I wrote the positive there, but you don't need the positive if you're answering this. Okay, that's when n is odd. I'll give you a minute to catch up. Oh, let me just put n there. I forgot our leading coefficient. Okay, we have, similar thing when n is even. But like I said before, when n is even, my n behaviors should be going in the same direction. Okay, so here we have n is even, and our leading coefficient is positive. All right, I'm going to have, as x approaches infinity, f of x is going to approach infinity. And then on the opposite side, when x approaches negative infinity, okay, this is where it changes. F of x will approach positive infinity. They're both going to the same direction. All right, and then the last one, when we have a negative leading coefficient, okay, that's going to flip us upside down. Right, but we still have the same n behavior. Here, as x approaches infinity, our function goes down to negative infinity. Same over here, when x approaches negative infinity, f of x also approaches negative infinity. All right, so these are our four situations. Now, this, how do I want to say it? This way of expressing is new and maybe a little confusing. So as long as as long as you can say that the end behavior is going up to the right or down to the left or so on and so forth, okay, you'll be okay. Now, we're going to see stuff like this at the end of the year when we talk about something called limits, all right, but we'll hold off on that for now. I don't want to overwhelm you guys. All right, so we're just going to go through a couple examples of this with the 5 minutes we have left. And this is how you're going to have a question or two tonight, and this is how it will look. All right, so I'm just going to move down. All right, so what we're going to do, another way they might say it is to describe the left and right hand behavior. And then I'll give you a function. And then they'll give you the function. All right, so pretty much all you're doing is you're trying to figure out which one of these four situations your polynomial best models. So again, you need two things. You need the degree and you need the leading coefficient. All right, so we're just going to focus on the front there. So the first thing you say to yourself, is it even or is it odd? All right, so we have x to the third. So it's an odd function. So right away, you don't have to worry about these two even function problems. And then our leading coefficient is positive, right? It's 1/4. Now, it doesn't matter what that number is. It could be a billion, all right? Just as long as it's positive, that's all we care about. So your answer, okay, would be as x approaches infinity, right? So as we're going to the right, this is our situation here. N is odd and n is positive. Okay, so you're literally just going to pretty much copy this down. So as x approaches infinity, f of x approaches infinity. As x approaches negative infinity, f of x approaches negative infinity. right? So none of this really matters for now. Okay, we'll get to when we have to take that into account. But right now we're just looking at our leading term. Okay, another way you can just say this verbally if you're getting confused by this, okay, is that the graph it rises to the right, okay, and it falls to the left. All right, so if you don't feel comfortable writing it out like this, okay, you can write in words what's happening. Okay, and this, I mean, this one kind of fits a little better with how they might express it with left hand and right hand behavior, right? So you could say, or to the right, the graph rises, to the left, the graph falls. All right, so just quickly to go through these, here we would say to the right, the graph falls, to the left, the graph rises. Here you could say both to the left and the right, the graph rises, both to the left and to the right, the graph falls. Any questions? All right, so just to kind of give you a heads up, right, we're doing this because what we're going to do eventually is we're going to be able to kind of sketch a graph with key proponents of our polynomial. Okay, so this is one of our key proponents, the end behavior. Right, so I mean, obviously now it's different, but when I was a student, the whole thing was, oh, you're not going to have a calculator in your pocket when you're growing up. Well, guess what? Now we do. But this would be an example of, if you didn't have a calculator and you had to sketch a graph, right? This is one of the steps that you would take.